All right, so let us discuss how to find vector equation for straight line. So this first example is rather simple. The next example will be more general case. So let me use straight line 2x, and then we want to find vector equation. So the graph of this straight line looks like this with the slope 2. Well, first step is to pick a point P on this line. So there are many points. Let me pick 1 point, 1, 2. Okay, so then we can think of the vector OP. So we have one vector OP like this. And whenever you pick a point Q on the line, we have a vector OQ, like this. So two vectors share the same direction. So we can stretch vector OP to have the same magnitude. So vector OQ is a scalar multiple of vector OP. That means vector OP, vector OQ, vector OQ is scalar multiple of OP for some t. Okay, so what we want to do is to collect infinite many vectors so that the collection of terminal points will represent this straight line. So whenever you pick a point Q, you can find appropriate t so that OQ is a multiple of OP. Okay, so to express this line, we consider collection of vectors t times 1, 2, or so to express the line, we consider the collection of vectors t times 1, 2, or t, 2, t. Again, the idea is we want to collect all the terminal points of the vectors where t can be any real number. So t can be any real number. If you think this is too long, you can say t belongs to capital R or fancy R. So this fancy R is the set of all real numbers. So let me quickly summarize the idea. We can pick any point P, then any vector OQ is a multiple of vector OP. So using the parameter t, we can find vector equation. Next, we can find the parameter equation as well. So to find the parameter equation, we can recycle our vector equation. So in the previous slide, we found the vector equation t, 2t, so you can name this, say, R of t. This is just naming. So now that we know the x component, y component, you can indicate x of t, the first component, t, and y of t, the second component, 2t. So this is a parametric equation for the straight line y equals 2x. Okay, so for given Cartesian equation y equals 2x, we found the vector equation and parametric equation. Actually, we can eliminate the parameter t to get back to this Cartesian equation. So we want to, once you eliminate t, then you will get back to Cartesian equation. Here, once you solve this for t, we have t equals x. And then our y becomes 2 times this t. You replace this t by x. So this is our original equation, y equals 2x.